Hello, everyone, and welcome to another opportunity to learn about data science. My name is Matt Hirschey, and I'm really excited today that we have Julia Silge who will be joining us to tell us about tidy models and modeling and machine learning, all in the Tidyverse. It's a unique opportunity to learn from one of the experts who is building and developing some of these tools that we all use and love in order to both learn and carry out some of these data science tools. So, without any further ado, what I'm going to do is try to figure out my echo. But what I'm going to do is join Julia. So, Julia, hello and welcome.
Thank you so much for having me.
All right. One of the things I'm going to ask to make sure Julia and also Akshay, who's waiting in the wings, is to make sure that you don't have the YouTube page open. That might be providing some feedback or interference. So just make sure that those are closed. And excellent. So I'm really excited to talk to you today because you have been both an inspiration to me in my own data science journey and learning, but then also so many of you watching have also asked, questions about modeling and machine learning, and this is going to be a great opportunity to really get into this. So the forum and the format today is just to let all of the viewers know is that we'll have a little bit of a Q&A at the beginning, really get to know Julia and get to know some of these tools. Then we're going to break away, and Akshay Bareja, one of our longtime contributors to this learning series, will give us a walkthrough of some of the tidy models tools, and perhaps will be showing us some principal component analysis or some other machine learning tools. We're then going to bring Julia back, and we're going to open this up to the community for like an AMA style sort of rapid fire. So if you all have questions that you want to ask Julia, please go ahead, put those in the chat in any time. We'll go ahead and curate those and make sure that we get all of the questions asked. So with that in mind, and again, this is going to be sort of interactive with the community, as interactive as virtual can be. So if there's any questions that come up anytime in the chat, go ahead and put them there. So Julia, I'm curious. Our data science community oftentimes starts with this "about me" slide, and this is actually foreign to me, coming from the sort of hardcore biomedical sciences, which usually we have somebody to introduce us, so we don't have to introduce ourselves. But since this is our sort of community type event, I will ask you to introduce yourself, and why don't you tell us about yourself?
Sure, sure. So yeah, my name is Julia Silge, and my academic background is in physics and astronomy, and I had a little bit of a winding career path, in academia, teaching and doing research, and eventually left academia, and then had a couple of kind of random jobs, doing things like I worked for an ed tech startup. Actually spent a couple years as a stay-at-home mom, and about 5 years ago, I guess in the other order, but and about 5 years ago, I made a transition into data science, and I had a quantitative background, a background in coding, but I didn't really have really like modern data science, either coding skills or some of the like modern machine learning and modeling skills that are used now. And so I started learning as much as I could, kind of updating my coding skills to what are used now, and made this career transition into data science. So my first job, where my title was data scientist, was at a non-profit consulting firm, or a consulting firm that did like statistics and data science consulting, which was a really great like a great sort of first place to be able to do data science, to have a lot of impact, work on really great projects with really amazing coworkers. And then I was a data scientist at Stack Overflow for quite a while. And now, for coming up on a year now, I work at RStudio. And RStudio, my title is technically software engineer, which is pretty interesting to kind of think about, like, whoa, is that what I am now? Is that what I do? But the answer is yes. I that's what I do. I now like develop open source software for my day job. So it's kind of interesting to think about, maybe when I was at Stack Overflow, my job was kind of 80%, 20% analyzing data, 20% building tools, like internal tools, internal R packages, developing open source software. And now I would say it's like flipped, where I spend 80% of my time building tools, writing open source software, and then maybe like 20% of my time actually analyzing data, usually for the purpose of either teaching or something internal at RStudio.
So then, why R, and when did you fall in love with it?
So I would say my computational background is like C and Fortran and stuff like that. And I like 5-ish years ago, when it was time to, hey, like learn something that I can get a job with now.
Yeah.
Not that people can't get jobs with C, but I started learning Python first, and then kind of got exposed. I didn't actually even know there was such a language as R. I'd never heard of it ever. And I was like, oh, what is this R thing? And I started learning R. I think I was exposed to it through the like one of the big MOOCs, like one of the big Coursera MOOCs, and I loved it. I think what made me click with R was it is something that has a very functional approach to data analysis. And I am someone that really loves functional programming and does not really love object-oriented programming so much. And so the very sort of Pythonic way, I was kind of like, all right, fine, I don't love this. And then the sort of, so I learned our Tidyverse first. Like I learned our with dplyr, even with purr, like purr already existed when I started learning R. And so like learning R from this functional first, R has this kind of lispy background and history. So learning R with this functional flavor to it, I was like, oh yes, perfect. I love it. This is exactly how I think about data analysis, how I think about dealing with data. And it's like just the right flavor for me. And also pretty soon after being exposed to R, I was exposed to the R community. And I was like a physics major as a very young woman, and then was in grad school as an astrophysics. And when I had decided to go back into this technical field, I'm going to update my skills and go back into this work, I mentally really had geared myself up, like, okay, I'm going to go back in there. It's going to be rough, but I'm going to do it. And engaging with the R community, my experience was totally the opposite. Even like I found this community that was fun and creative and welcoming and full of interesting people doing interesting things. And so it was kind of the combination of those two aspects of learning R that made me love it, that made me realize I really like being part of this community, that made me realize that it's a good fit for how my brain works, how I think about data analysis.
So let's dig in that a little deeper, because we have a pretty broad audience here. I'm curious, people have talked about a functional programming language versus an object-oriented programming language. If you just broke down and maybe a simple analogy, like how do you think about the difference between these two like general concepts?
Yeah, so I'm not someone who has formal computer science training, so I apologize if what I'm about to say is a little bit wrong, but I'll give it a go. So like functional programming is focused on functions, where you put inputs into functions and you only focus on what comes out of them. You don't have what are called side effects. So things that might happen that are side effects that you might be familiar with is like, printing something to the screen, or changing something about the state of if you think about your R environment, for example, like changing something in your R environment, that's not the output of the function that you created. So functional programming, you just put in inputs, and you just have outputs that are come out. Object-oriented programming instead views like an object as important, and then you have usually methods that are like getters and setters, where you go in and out, and you can change things that are in the object. And so you're less concerned with things like side effects and changing state. Like you're more okay with it, with like changing state.
I ask partially my curiosity of how you're thinking about it. Also partially because I, like you, don't have formal training in computer science. But I think that more and more often, people are getting exposed to what we at Duke and in our community are calling computational thinking, which is really approaches to thinking about computation. It's a little bit meta, but approaches to how you're going to solve a problem. And it was really interesting that you said that you find one type of programming approach like works for your brain, I think you said. And so it's interesting because, of course, there are the flame wars on R versus Python, or whatever the best tool is, and so on. And my approach is, an analogy that I recently sort of gave in one of my sort of teaching videos, is that it doesn't really matter what tool you use, because you can think of yourself as a chef. And if you think of yourself as a chef, then it doesn't matter, I said on the fly, if you grill or you sous vide. At the end of the day, do you create the meal at the end? And the tools that you use are going to be less important than, especially in data science, there's usually a goal, an outcome, a task, something that you want to do. And I think that, finding a language that works for you and resonates with your brain and your wiring and so on is going to be most important.
Yeah, absolutely. And there's like really such well-developed, mature tooling for doing, data analytics, data science in both Python and R worlds. Like you can't really go wrong.
Yeah. So then I'm really wanting to know, because many in our community are self-taught, and in fact, part of my effort here is to bring resources and ideas to this growing community to continue to learn, which is why we wanted to really sort of get into some of the tidymodels and so on. But I want to dig a little bit deeper, because you said that you decided to dive in and you took a MOOC, but what did the early days of you deciding, okay, this is something that I want to invest in and something I feel like I need to know, and I'm eager and curious about it. What did those early days look like?
So let's see, what did they look like? So I came from this background in astrophysics, and what I actually did, like say during my PhD was and postdoc, and during those days when I was involved in research, was I would go and take data for maybe like a week at a time, once a quarter or something. But what I did the rest of the time was analyze, write code to analyze data, write about it, make plots, communicate about what it meant. And if I fast forward sort of a couple decades later, and I saw I started to see people from either like my cohort, like people around my age who were making career changes, or even at that time, like people who were younger than me, like making this career change into this thing called data science. And I would talk to them and be like, so what is it that you do for your job? And they'd say like, Well, I write code to analyze data, and I make plots, and I write about what it means, and I communicate, like I, communicate with people in the business. I'd be like, wait a minute, that was my favorite part. That's what I like doing about, when I was doing research. Like that was what I liked about it. There's a job for that now. Perfect. That's what I want to do. So kind of realizing that there was kind of a profession forming around did this kind of skill set was a big motivator for me to look into more deeply what specifically what kind of concrete skills do people need to have to like move into that from where I was. At the time I already had sort of on paper, like the right kind of degree to move into that kind of skill, but like what did I need to make a transition in, and like what areas in my own sort of knowledge need to be filled in to be able to move over. So I would say those were the things that sort of initially piqued my interest and made me want to look in, was kind of this sort of forming around this set of skills as a professional identity. I would say before that, people who were moving into industry, physics or astrophysics were going, they were doing very similar things, but they were maybe going into finance and, building models for trading. Maybe they were going more to a more engineering role, maybe moving into software engineering. But I had not yet, and those held. I found myself less drawn to how those roles were described or what people said they did all day. And so it was when this description of this set of tasks as a job started happening. I was like, wait, yes, that is what I want to do, that I really became interested.
I see. I personally feel lucky that the tools that are available today have helped me sort of quickly get to where I am, as opposed to previously, 5 years ago, 10 years ago, the tools that are available were just more rudimentary, and so it's quite, I guess, lucky that the tools are available. So one of the things that I want to touch about is some of the tools that you are starting to develop and build. And so we'll talk a little bit about tidymodels, but why don't you give us just a brief introduction to tidymodels and the motivation, what it is and the motivation for it and so on.
Yeah, so tidymodels is a framework in R for modeling and machine learning. So it is a set of R packages. So if you've ever used the Tidyverse for data visualization, reshaping, manipulation, you've probably typed library Tidyverse, and then you've had functions for summarizing, for making plots. So when you type library tidymodels, you load a set of packages that are each of which address a certain part of the modeling process. So one of the packages, for example, has functions for data resampling, like breaking apart data sets into resamples to get better, more reliable results. And one of that one is called RSample. One of the packages is for model evaluation, for being able to say, hey, I'm at the end, I have a fitted model and I want to be able to see how it's doing. And that model is called yardstick. So it's a set of packages. It's broken up into different pieces to improve our ability to maintain the packages in a more fluent and more responsible way, rather than having like one ginormous meta package. Some of the goals of tidymodels are to provide a like a unified, cohesive way for us as human beings to interact with models in R. The modeling ecosystem in R is a little bit of a wild west. If you've worked with a little bit of R and a little bit of Python, you may have noticed that in Python, it's like, there is one way to do something, and it is the Pythonic way. And like there's one way. And in R, it's like, look, there's 5 packages that do the same thing. It's like there's literally like 5 ways to do everything. And I think there are pros and cons to both approaches. One of the cons of having so many like ways to do everything is that when you want to do one kind of task, like fit a model to data, but there are actually, literally, I'm not joking, a dozen interfaces to that same kind of task, it just becomes overwhelming, exhausting, difficult to build, for any individual analyst to be able to learn that, to be able to build good work, analysis scripts to be able to do that. So one of the goals is to provide a unified API to models in R. So the analogy here would be scikit-learn in Python. If you've ever used scikit-learn and you're like, oh, I go to one place for all the models. So the analogy here for tidymodels will be that. If you've ever used, it's not the first time this has been, someone has tried to do this in R. If you've used caret in R, that was an earlier iteration at the same task by Max Kuhn, who is my boss at RStudio. So I work for and with Max on tidymodels. So this is like a new, more modern take on sort of that same sort of goal of a unified API for models. If you MLR or MLR3, you notice that the MLR people also have gone through multiple iterations. It's another approach in R for, hey, there's all these models out there. I want to have one approach to it. So other goals that the tidymodels framework has is to use tidyverse data structures and principles. So some of these things mean reusable data structures that you don't have to keep like reshaping awkwardly your data. You use tidy data, you know it, you love it, you know how to make plots with it, and you can do that with your model data as well. You know how to use ggplot2 and dplyr. If you like those, then you might look into using tidymodels. The last goal that I want to talk about is to really think about carefully what is good statistical practice when it comes to modeling machine learning, and to build that in to the defaults, the design of how you use the functions, and sort of a little bit of like the guardrails that are there in the function. So I'd kind of summarize those 3 things as what tidymodels is, like a unified interface to models, using tidyverse principles, data structures, and syntax, and with the goal of good statistical practice.
So then just 2 quick questions before we bring Akshay on to give us a walkthrough of this. How has the uptake been so far? I'm sure one of your key roles at Stack Overflow was looking at use of Stack Overflow and counting things sort of within how people are querying and sort of what those trends look like. So I assume that you and Max and others have looked deeply at how the tidymodels is going. So give us a sense so far of the uptake or the use so far.
Yeah, we've seen a really big change this year. I would say at the beginning of this year, tidymodels had just barely gotten to the point where it was mature enough to be used in real projects, like your real world work. It was in a bit of a exploratory kind of approach before, say, this past January. And maybe as of this past RStudio Conf this past year into the early spring, it really kind of crossed the barrier into being something that was ready to be used for production work, for your real analysis with your real data at your job, And over the course of this year, we have seen a really enormous increase in use. I think that that has come, when you have something like that happen, it definitely comes along with some growing pains where you all of a sudden discover the edge cases that maybe you thought weren't so important ahead of time, and you're like, oh gosh, no, we got to fix that. That's something that we really need to solve. So that's been exciting to see and also interesting to walk through. If you want to talk about absolute numbers, a very mature framework like Carrot probably still has more an absolute number of users, but it will as we see things, shift and change over, maybe the coming year or something, it'll be interesting to watch that. If people come and talk to us about Carrot versus tidymodels, we usually say, there's no reason to redo a project that's in Carrot right now into tidymodels. Like there's no reason to rewrite it. If you're going to start a new project, definitely start it in tidymodels because Carrot is going to continue to be maintained, but there's no new development in Carrot, like no new features or anything. New development is happening in tidymodels. So if it's, if you have some reason to rewrite something, I would rewrite it in tidymodels. If you're starting a new project, I would do it in tidymodels, but there's no reason to, throw away Carrot code or anything like that.
I see. Okay, so I have one more question for you, but before that, I'm actually going to bring Akshay on here. So Akshay, welcome. How are you doing, Akshay? Let's see, is Akshay there? Akshay.
I see him. Is he joining us?
Let's see. All right.
Can you hear us?
All right. Well, I was going to have Akshay tell us. Let's see here. We can go like this, and we can get. Anyhow, I was going to ask Akshay what he was going to tell us about today. But what I can do is I can just very simply. I want to get a sense. I think he's going to be telling us about some principal component analysis, and what I want to do.
Hello.
Yeah, Akshay, are you there? So Akshay's speaker seems to be having some problems. All right, we'll let him work those out. But what I was going to do is, I think he's going to be telling us about some principal component analysis and one of the walkthroughs. And so if that's the case, the last thing I wanted to ask you is to give us a sense of where this type of analysis lives within the modeling and machine learning ecosystem. And so one of the distinctions that you've made is a distinction between modeling and machine learning. So
sorry, Matt, I can't hear you.
Okay. We'll get Akshay sort of straightened out. But the thing that I wanted to ask you though was about the this distinction and how you make this distinction between modeling and machine learning, and why you still make this distinction.
So I tend to use those words in not super different ways. I tend to use the words machine learning and modeling in mostly interchangeable ways, like in interchangeable situations. When people say machine learning, they often will be talking about building a model with the purpose of prediction. Like where their main goal is they want accurate predictions. And if someone is talking about modeling, they may be talking about other purposes. So they may be talking about building a model for maybe the principle of like inference, like understanding not just like I want as accurate a prediction as possible, but maybe I want to understand why, like what are the relationships between inputs that I have and some outputs that I have, or they maybe want to just build a descriptive model where they're describing the relationships that they have in their data. They're not really interested in like a why kind of question, but just like what are the relationships like. So I think that in general use, when people say modeling, they might be more in the descriptive, inferential kind of regime. And when people say machine learning, they might be leaning towards more the prediction kind of regime. But the word, I don't think those words mean drastically different things. And I often will maybe use both to kind of make a big tent to say I'm kind of talking about all of them because we use really similar techniques for all of it. I think that often if our goal is building a descriptive or an inferential model, it can be important still to measure things about the predictive capacity of our model and that's often something that goes underreported or undermeasured when it comes to say inferential models, but they can really help us understand, like, is this model actually good for anything? And so if we're going to talk about principal component analysis in this walkthrough, principal component analysis, if you talk about maybe like the whole process of modeling, it can be used, say, in a descriptive sense to say, here are how these variables are related to each other. Here's where the most how these variables are most different from each other, and like where we see the different various variances. We also can use it in a predictive sense. We might use it as a way to do dimensionality reduction, and then be able to build features for prediction that work better than the variables that we had to start with. So you can use principal component analysis in a couple of different contexts within this sort of modeling and machine learning umbrella. So I would say that it is good kind of in the descriptive sense, and then it's good in the feature engineering part of the modeling process.
All right, excellent. So let's go ahead and Julia, thank you. We'll bring you back at the end with an opportunity for the audience to ask some questions, but let's go ahead and bring Akshay on. Akshay, are you there? Let's see if we can get Akshay on. Some of you have said that my audio is not quite perfect. Still working on this here, but Akshay, let's see. Akshay, Akshay is up.
Yeah, Matt, I'm there.
All right, excellent. Go ahead.
I can't hear you through Ecamm, but I can hear you on YouTube. Should I start? I can start the code along. Right. Excellent. Can you see my screen? I can't hear you through Ecamm, but I can hear you on YouTube. Should I start? Okay, so I guess I'll just go ahead with the walkthrough. Thank you everyone for joining us, and thank you, Julia. So I heard that Julia gave a nice introduction to PCA, so that's good. So I won't spend much time describing principal component analysis. I'll just go over the code. So before we begin, for anyone who wants to code along or code later, hopefully you have cloned Matt's meetup repo. And if you have and set up a project in RStudio, just go to Git at your Git pane and click on this pull button. and just to make sure that everything is up to date. And once you've done that, go to the folder marked 2020_11. Let's give me a second. And in that folder, you should see a file named tidymodels.rmd, which is the markdown file that has the code. And typically, we use code that we've generated ourselves to answer a question of biological interest. But today, I will be presenting a vignette that was produced by Dr. Alison Horst for a couple of reasons. One is it's a really nice, nicely done walkthrough of how to perform PCA using tidymodels, and it also introduces the very useful and very cute Farmer Penguins dataset. So let's begin. And you can see, as Julia mentioned, tidymodels is kind of like Tidyverse insofar as it's like a meta package that contains lots of smaller, useful packages. So as you can see in the setup chunk, there's tidymodels, Tidyverse, and Farmer Penguins is the package you need to be able to access the Farmer Penguins dataset. And if you don't have that, you can download that from CRAN. And also in the setup section, setup chunk, you'll see that there's we've set the theme using theme_set. And this is a nice way of making sure that all the subsequent plots have the same theme, instead of having to always type in plus theme_minimal or whatever your favorite theme is. So we just run that chunk. And I've included some really useful links. One is, of course, to the link from which I copied most of this code. Julia has also done a really nice PCA walkthrough using a dataset on cocktails. She has a blog post, and it also has recorded a video of her going through this PCA. So please refer to that. Please watch that. And then there's the tidymodels website, which was released earlier this year, and it's excellent. It's very thorough. Julia and Max Kuhn are currently working on a tidymodels book. And if you click on this link, you can see it. It's being developed right now, but there's already a lot of great content. So the first thing we want to do is we want to load Penguins dataset, and so that's just data penguins. And you will see, so if we go to the environment page, you'll see that there are a couple of datasets that come with penguins. There's penguins raw and just penguins. So they're similar, except penguins_raw has many more variables. So if we just click on penguins itself, we can see that it has 344 observations in 8 columns, 8 variables. You'll see that the first column has to do with species. So that's the species of penguins. And so if you wanted to see how many species there are, you can just use the distinct function. We can see that there are 3 species. So what we'll do is we'll use principal component analysis to visualize these 3 species so that we can maybe learn something about them in terms of their similarities or differences. So step 1 for doing PCA or doing any other kind of modeling is to first write down a recipe. And so if we go down to line 32, penguin_recipe, that's the recipe we're creating. And so the recipe, to create a recipe, you first need to use the recipe function. And the good thing about tidymodels is it uses the same model formula system that base R uses. So if you were used to doing modeling in base R, it should be very easy to do modeling using tidymodels. So if you have done modeling in base R, you will be familiar with this tilde symbol. And since we're doing, so typically with the tilde symbol, if you were doing, let's say, a linear or logistic regression, you would have your independent variable on the left-hand side of the tilde, and then all your predictor or your dependent variable on the left-hand side, and then all your independent variables on the right-hand side. Now, or one or more. In this case, since we're not predicting anything, we have nothing to the left of the tilde. And since we want to use all our usable variables for PCA, we just put this dot symbol instead of having to type out all the variables. And then we do comma, and we have to specify the data set we're using, and that's just called penguins. So we do data equals penguins. And then we pipe that into this function that, if you are not familiar with tidymodels, will be new to you. It's called update_role. And briefly, what it does is it allows us to specify which variables we don't want to include in PCA. And so for PCA, we can only use numeric variables. We can specify that we don't want these variables to be included, but we don't. But this update_role function allows us to not use some variables in a model, but it doesn't. But it also allows us to keep the variables in case we need to use them later on. And so to do that, we can specify. You can use this argument called new_role. We can just set it equal to ID. And then we pipe that into, so this is really nice. Just like, if you're familiar with dplyr or ggplot, there's this nice line-by-line kind of addition of operations. So it makes things very clear to someone reading your code what you're doing. Each step typically does one or two things. So in this case, once we've updated the roles, we then want to, let's say we want to remove all the NAs. So I didn't point it out, but the penguins data set does have some NA values. So we can use this step_NA omit. And the what are we emitting? We're emitting all, what are we omitting? All the NAs for all the predictors. So we just do all_predictors as, that's what we put in the step_NA omit. And then we pipe that into step_normalize. And again, we apply that to all the predictors. So step_normalize, if you've done PCA using base R, it's equivalent to scale, where you have the center and scale arguments set to true. And so what step_normalize does is it takes your variables and it makes sure that the mean of the variables becomes 0 and the standard deviation becomes 1. And this is critical for PCA. And then finally, we pipe all of that into the step_PCA function, which is what actually does PCA, using all the predictors. And we set ID equals PCA. And so far what we've done, these lines 33 to 37, that's just like we've written down the recipe. We need to then pipe this recipe into prep. And what the prep function does is it applies the recipe to our data set. So let's go ahead and do all of that. And then we can just take a look at our penguin recipe. And if we look at the console, we can see what the inputs are. So how many data points, tells us how many incomplete rows there are. It also tells us what the operations, have been performed. So that's, of course, removing the rows that have NAs, centering and scaling, and extracting the principal components. So, so there's this function called tidy that, so a lot of things in R, a lot of output in R is in an untidy or unwieldy format. And so since we're working within the tidyverse, all our data sets need to be in a tidy format. So that's what the tidy function does. We can apply it to our recipe, and we can see in a nice, we have a tibble that has 3 rows that correspond to the 3 operations we performed. But what we can do is we can use the tidy function and specify the ID. So in this case, let's say PCA, if we want to see the output of the PCA. So if we just run that, line 43, we now see that this should be familiar to anyone who's done PCA, except typically when you do this in base R, you will get the output in an untidy format. So this tidies it up, the tidy function. And so we can see that the first three principal components. So there are 4 variables that we're using as input. And so there'll be 4 principal components that are produced by these variables. So the way principal components are produced is or created is that they are the linear combination of your original variables. So what that means is, so this value column here, that corresponds to the loadings, and I think of them as coefficients that we use to linearly combine our original variables. So all that means is, to make principal component 1, we take bill length, we multiply it by this value, and then we add that to bill depth, multiply it by this value, and so on for the remaining 2 variables. And so the thing with principal components, so what we'll be doing here, so Julia mentioned the principal components can be used for a lot of, principal component analysis can be used for a lot of things, one of which is feature engineering. And so, for example, let's say you had hundreds of variables and you wanted to use them as covariates in a regression model. You would run the risk of overfitting. So what you could do is you could do principal component analysis and just take the top few principal components that account for the majority of the variability of the variation, and then drastically reduce the number of covariates. But what we will be doing now is just visualizing our data in this new space that we've created. So the first thing we can do is we can visualize the loadings themselves. So to do that, we can take our penguin underscore recipe, and then we pipe it into this tidy function as we did previously. And then we can use the mutate function to, so you can see component refers to the principal components themselves. And we can use this fct underscore in order function to make sure that we, the plots that we produce are in the order of the principal components. So in this case, from 1 to 4. And then we pipe all of that into ggplot. And we put the value, which corresponds to our loadings, on the x-axis, and the terms that correspond to the original variables on the y-axis. And then we just do fill equals terms to give the bars some color. And then we're using geom underscore call, because this is we want to make a bar graph. We do show.legend equals false because we don't want the legend. Facet underscore wrap tilde component, because we are creating as many plots as we have principal components. So we'll be making 4 plots. And so if we run all of that, it's just taking a second to run, we can see we have this nice plot here for the 4 principal components. And one thing that I haven't shown, but is shown in the original walkthrough, is a jackstraw plot or an elbow plot that plots the proportion of variance accounted for by each principal component. And in that plot, you will see that PC1 accounts for the majority of the variance. I think it's 60%. So that's the most interesting principal component. And you can see, if you look at that, if you look at PC1, you can see the flipper length, body mass, and bill length all kind of go together. So indicating that they're correlated, whereas bill depth goes in the other direction. So this suggests that bigger penguins tend to have narrower. So the bill depth is the width of the bill. So they tend to have narrower bills. So we can see if this is true later on. So another useful thing we can do is we can, so since I said principal component 1 accounts for the majority of the variance, what we can do is we can use the first 2 principal components, PC1 and PC2, as new axes. And we can plot our original data on this new 2D space. And this is also known as projecting our data. So we can do that, and we can also represent the original variables, the original 4 variables, on this space. So what we can do is we can, so previously I was piping in penguin_recipe into the tidy function. We can save that as an object called penguin_PCA. And what we'll want to do is we want to, for the purposes of plotting, we want to, oh, you can see that we're nearly done. So I just want to point out one important thing is if we go back to penguin_recipe, we see that there's a recipe. There's a really nice function called juice if we want to see what the principal component scores are for the recipe. And so there's principal component scores. And I'm going to wrap this up just by running the code that we need to run for our plots. I'm not seeing it. Anyway, we can do the first plot, which is it's taking a while to load, but in the interest of time, I encourage you to run this yourselves and or just go through the walkthrough. Thank you for your attention.
All right. Thank you, Akshay. Julia, we're back on together. And
awesome.
It's probably not too often that you get to see someone else sort of live walking through some of the tools that you made. So perhaps you were sort of frivolously making notes of, oh, we should change this or that or whatever. So we have a chance now. I'll ask.
It's always really exciting. Oh, sorry.
Go ahead.
Oh, so I was just going to say, like, it's really exciting when we see people use our work in real life, or we hear about how are people using it in real projects that they're using. That's always really great.
Yeah. So we'll ask the community and give them an opportunity to just fire away in the comments, ask really anything that they want of you. We could also bring Akshay back on if it's some of the technical questions about that data set and the code. The code is available. I put the GitHub link in the comments, so if you guys want to go and look at the code and follow along, you guys can do that later. But while we're letting the sort of community think of the questions they want to ask, I want to ask you something that I think comes up quite often. And so you are giving, we'll say people like me, a superpower, right? That candidly, I have no business wielding, right? I'm not qualified. I don't have the training, or so people like me and perhaps starting out might feel. So how do you then find the balance between giving people tools to do things that they could have never done before, but at the same time, those tools might then lead them down a wrong path because they have such capable powers? Candidly, like a principal component analysis. I mean, this is a very sophisticated dimensionality reduction algorithm that that Akshay did on a Penguins data set. So how do you think about balancing this sort of power and responsibility?
Yeah, it's a great point. So I think a good first thing to think about is like as a tool builder or as like someone who deals with data, is to really wrestle with like, where do you stand, and or what is your opinion on like making tools accessible? Yeah. Making tools what are we going to do in terms of like communication? What are you going to do in terms of like in terms of what do you think, quote, regular people should be allowed to do? And like basically what is your opinion in terms of like, are there certain things that only like a licensed statistician should be allowed to do? I first heard, I think, Hadley say this in a talk, and I can't remember if he was quoting someone else, but like what he said is that like we have a lot of evidence that like abstinence only education does not work, and I really think it does not work when it comes to stats and machine learning. Like, people have access to data in their jobs, and they know about this stuff that's out there, like they know about random forest. They know that the stuff is out there, and they're not gonna not use it because it's like, oh, I heard it's hard to apply well, or I heard that you can make mistakes, or I heard, or like, oh no, the uptight statistician told me I'm not doing it right. Like people are not going to not do it because because someone told them they're not doing it perfectly. They're going to do it anyway. I think the analogy is perfect. I think it's a literally perfect analogy. And because, and so what do? We do like harm reduction. We do like, and what does that mean in terms of like tool building? What does it mean in terms of, education, in terms of documentation building? It means that all kinds of people with all kinds of backgrounds and education levels are going to be attempting to use these kinds of tools. And so you build like when we write our books, when we write our documentation, when we build the tooling that we do it with the mindset that like people from a wide variety of backgrounds are going to be using them. And so we have goals to encourage good statistical practice by how we set things up, by both in terms of how easy is it to get on the right path with what we're doing, and then how do we, like, what do we show when we demonstrate? What are in examples? And then how do we teach? How do we demonstrate? What are in our materials and books? So I think it's a little bit of a a philosophical question, and probably people have different opinions on this, right? But I think as a if you might have a different opinion if you're like in an organization and you're like, okay, who do we want building our models, having access to our data? We want to make that the responsibility of the people we know have the most appropriate background. As someone who's a tool builder, I think I want to acknowledge the reality that a lot of different kind of people are going to be doing it and build tools with that in mind.
Sure. No, that's great. Akshay asks a question. He says, is there a plan to integrate tidymodels with deep learning tools like Keras and Torch? Of course, one of the more exciting developments was the integration of a native library for Torch into the sort of R ecosystem. So maybe you could sort of tip the cards and tell us what some of the future looks like.
Yeah, so we already have an integration with Keras. So you can use tidymodels with Keras. So for example, you can use it for like with like a dense network. I mean, we don't have support for every kind of network architecture, but we do have integration with Keras already. We are pretty excited about Torch because Torch doesn't involve going through Reticulate and Python. Like it involves just going like a native for our kind of situation. And so we're starting with the same stuff that we started with for Keras, which is like a dense perceptron, like starting with those sort of simpler network architectures that you can get started with, and they will and then we'll go from there and see what we can build. So there's already some there's already neural networks in tidymodels, and right now they are either some of those ones that are written in R or the Keras ones, and then we're actively working on Torch right now.
Excellent. So then maybe because we're a little late on time, I'll just take an opportunity to ask you one final question. And I'm just curious, what excites you about sort of looking into the future, whether it's something, in the art community or ecosystem, or, within the modeling or machine learning landscape? Like, what are you really excited about right now?
So I'm somebody who really does care about and get excited about like how people work in like the real world, like their everyday getting their real work done kind of situation. And so one of the things that I've been working on some with like a set of user interviews of actually mostly our customers, our pro customers, and some like people who use our open source products as well, our like open source software as well, is this issue of like model management, model like kind of what people call like model ops or ML ops. So like you train a model, and then what do you do with it next? Like once you've got it trained, like what happens at this point? Probably you have it deployed somewhere, and then it's like then what? Then what? What like the analogy that often I think about it. It's like someone giving you a puppy as a gift, where you're like, oh yay, and then you're like. You're like a puppy, have a puppy. And like now we have to like start the process of like taking care of it and, doing all the sort of, like the kind of annoying stuff to take care of it. Working on like I am someone who actually cares about a lot of that nitty gritty and getting those details hammered out and helpful and I don't know if right is the a good word to use, but good fluent. And so figuring out how, like, what are the right tools for those kinds of jobs? What do we have already that fills those needs? Are there new things that need to be built to fill those needs? So that's something that I'm really excited about right now.
Excellent. Well, I just then want to thank you. That is sort of, I think, exciting for a lot of us. But I really want to let you know I appreciate your time, coming all this way, but taking taking all of the time out of your busy schedule for our community here. So thank you. And just to let other people know, if there's elements of this that you think somebody would like that hasn't seen this is going to be on YouTube in like 2 minutes. So this will be sort of live, and we'll share the links and all of this. But Julia, thank you. I hope that we can connect in person sometime.
Thank you so much for having me.
All right. Bye-bye.